Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video we will discuss about question number 20 of NEET Physics paper 2015. Question number 20. Three identical spherical sheets. So three hollow spheres are there, each of mass m and radius r are placed as shown in figure. So these are the 1, 2 and 3. Three hollow spheres are there, and the axis passing like that, touching these two spheres and the diameter of this sphere. This is x and x prime, which is touching two cells. These are the two cells, touching the two cells and passing through diameter of third cell. So this is third cell and the axis passing through the diameter. Moment of inertia of the system consisting of these three spherical cells about this axis will be what? This is a very simple question. Each of mass m and each sphere has radius r. So moment of inertia of the system is due to the moment of inertia of 1, 2 and 3 contribution from all these three spheres, I1, I2 and I3. The moment of inertia of this sphere about this axis is a tangent to this sphere. So the sphere, the axis is like this, so it is a tangent. About this, it is 2 by 3 mr square plus mr square. Using the parallel axis theorem, we will have I1 is a sphere about this hollow sphere. So about this mass m radius r, the moment of inertia I1 will be 2/3 mr square, and but the axis under consideration is this one. This is your x and x prime, so you use parallel axis theorem. This is not I1, this is, you can say, I0. This I consider as I1. So using parallel axis theorem, I have moment of inertia I1 will be I0 plus mh square, where m is the mass and square of this, that is r square. So this is 2 by 3 because I0 is this one, mr square plus mr square. So it is 5 by 3 mr square. So I1 is 5 by 3 mr square, and obviously I2 will also be a 5 by 3 mr square, because this is also the same sphere and this is also the same tangent. So I2 for this sphere, this axis, mass and radius r, it is again 5 by 3 mr square. This is your I2. What about I3? The sphere is like this and the axis x and x prime passes like that. That is about any diameter. So about any diameter, we know it is 2 by 3 mr square. So this will be 2 by 3 mr square. If I add them off, the moment of inertia of the system will be system of three spheres I1, I2, I3. I1 and I2 are same, so it is 2 times 5 by 3 mr square plus this is 2 by 3 mr square. Now this becomes, this is 10 by 3 mr square plus 2 by 3 mr square. So 10 plus 2 is 12. 12 by 3 mr square. So it is 4 mr square. So moment of inertia of the system is 4 by 3 mr square. It says that the moment of inertia of the system is 4 mr square. We are also having 4 mr square. So this is the answer to this question. Okay, thank you.